Hello students, in this video we'll see an example of computing the variance of a random variable from its PDF. Let's compute variance of x, where x is a random variable with PDF f of x is 4, and then the absolute value of 1/2 minus x on the interval 0 to 1 and 0 everywhere else. So we can check that this is a PDF. Clearly the function f is always non-negative. And if we integrate f, so if we look at the graph of f, here's x, here's f of x. We see that when we plug in 0, we're at the value 2. When I plug in the value 1/2, I'm at 0. And I plug in the value 1, I'm at 2 again. So the graph of my PDF looks like this. And we should also specify that there's going to be a jump here, so I should specify this not equal to those values, because we have jump values. And we'll put circles over here, and then 0 everywhere else. So we can see that this is a triangle with height 2 and base 1/2. So the area of this triangle over here is 1/2. The area of this triangle over here by symmetry is 1/2, and so the area under the graph is 1, therefore it is a valid PDF. So if we compute the expected value of the random variable, we have to break it into two parts. So we can note that we can also write this function f of x piecewise. Over here, it will be, when x is between 0 and 1/2, this is positive, so I will just have a 4 times 1/2 minus x, or 4 times x minus 1/2, which will simplify to 2 minus 4x, or 4x minus 2. This is for x between 0 and 1/2. This is for x between 1/2 and 1, and 0 everywhere else. So let's compute the expected value of x. The expected value of x will be the integral from 0 to 1/2 of x times this expression, 2 minus 4x dx, plus the integral from 1/2 to 1 of x times 4x minus 2 dx. We can integrate this. This will give us x squared, and then minus 4x squared will be minus 4/3 x cubed from 0 to 1/2, plus 4/3 x cubed minus x squared from 1/2 to 1. If we compute this, we'll have a 1/2 squared. That's going to be a quarter. Then I have a 4/3 times an eighth. 4/3 times an eighth is going to be 1/6. Then I'll have a plus 4/3 minus 1. And then minus, again, so I'll have 4/3 times an eighth. That's going to be a 1/6. And if I plug in a half over here, I'll have a negative 1/4. And so what happens over here is that this is going to be 1/4 minus 1/6 will be a 12th. This is also a 12th. So you have 2/12, so that will be 1/6. And then this term over here will be minus 3/3, so plus 1/3. So this will be 9/18, so a third plus a sixth is a half. So the expected value of x is 1/2. Now let's compute the variance of x. So the variance of x is the expected value of x squared minus the expected value of x quantity squared. And we know what this is. The expected value of x is a half, so this term over here is just going to give us minus 1/4. So this is going to be minus 1/4. So all that remains to find is the expected value of x squared. So we can do that now. So what will this be? This will be the integral from 0 to 1/2 of x squared times 2 minus 4x dx, plus the integral from 1/2 to 1 of x squared times 4x minus 2 dx. That's the expected value of x portion, and from this I will subtract off 1/4. So we continue. I have an antiderivative of 2x squared. That's going to be 2/3 x cubed. Then I have a minus 4x cubed. That's going to be minus x to the 4th power from 0 to 1/2. Plus, I'll have a 4x cubed. That will give me an x to the 4th power. Then I'll have a minus 2/3 x cubed from 1/2 to 1. And all this will be subtracted from, I will subtract 1/4 from all this result. So over here, we'll have 2/3 times an eighth. So 2/3 times an eighth is a 12th. So this will be equal to 1/12. And then I'll have 1 over 2 to the 4th power. That's a 1 over 16. Those are the first two terms. Then I'll have a 1 minus 2/3. That will be a plus 1/3. And if I plug in a half, I'll have a 16th. And over here, so I'm going to have a minus 1 over 16. And if I plug in a half over here, I'm going to have a minus 1/12. All this will be subtracted from 1/4. And so now let's just do a little bit more bookkeeping over here. So what we have over here is we have a 12th, so we'll have to put these in terms of 48ths. So this is 4 over 48, 3 over 48. So this will be a 1 over 48. And then I'll have another 1 over 48 over here. So that'll be 2 over 48, or 1 over 24. So this term and this term will be 1 over 24. So I'll have a 1 over 24 plus 1/3 minus 1/4. So I'll have a 1 over 24. And then these terms over here will be a plus 1/12, or 2 over 24. So I have 2 over 24 and 1 over 24. So this will be 3 over 24. And 3 over 24 is 1 over 8. So the variance of this random variable is 1 over 8. Thank you very much.